Okay, back again. This time we're going to look at our graph of y equals a sine bx. Remember before we talked about a, or the amplitude, and what a would do to the graph. And a would stretch it up and down depending on the higher a is, the longer it stretches up or down. Remember what b determined. B determined our period. The period is always found by taking 2 pi over your b. And the period tells us how long before the graph repeats itself. Now, we looked at different values for a, but we didn't look at different values for b. So this video is going to look at a sine bx. For example, we're going to look at y equals the sine of 1/2 x. Notice b equals 1/2 and a equals 1, as there's nothing there. To find our period, we know that we have to take 2 pi over b, which is going to be 2 pi over 1/2. Remember, keep, change, flip. So you would get 2 pi over 1 times 2 over 1 equals 4 pi. This is our period. So the only change that we're going to see here in this graph is that we're going to start at 0 as always, but we're going to go to 4 pi instead of 2 pi. Now, to figure out what lies in between, remember you have to break it into quarters. So, 1/4 of 4 pi equals just pi. So our first line here is going to be pi. And then you could take then half of 4 pi, and that's going to give you 2 pi. That goes in the middle. And we can see the pattern here. 3 pi will be our next point. That shouldn't be a problem. So let's look at, by the way, you could have taken your first value, which was pi. To get the third value, you just times it by 3. That's how we get the 3 pi. It's another way to get the 3 pi. Okay, now we have our period stretched out here from 0 to 4 pi. So understand now what b is doing to this graph. B is stretching it out long ways or pushing it in, but it is not dealing with up and down. That was the a, or the amplitude. B deals with the period. So we handle this the same way. We start at 0. So if y equals 0, or x equals 0, my apologies, and I'm putting it into y equals the sine of 1/2 x, I would have y equals the sine of 1/2 times 0, which equals the sine of 0. And we know that the sine of 0 is, 0. So at 0, we go to 0. Now let's do pi. If x equals pi, and notice I'm just putting in these values, I get y equals the sine of 1/2 times pi, which is the sine of pi over 2. And what is the sine of pi over 2? 1. So when x is pi, my value goes to 1. And then let's try the next one. When x equals 2 pi, y would equal the sine of 1/2 times 2 pi, which equals the sine of pi, which equals 0. So we're back to 0 at 2 pi. Now let's do 3 pi. If x equals 3 pi, we have y equals the sine of 1/2 times 3 pi equals the sine of 3 pi over 2, which is 270 degrees. and that is going to be -1. So for 3 pi, we've got to go down here to -1. And then let's do our 4 pi. If x equals 4 pi, y equals the sine of 1/2 times 4 pi equals the sine of 2 pi equals, what is the sine of 2 pi? 0. So 4 pi is 0. So when we draw our graph, we again go to 1, to 0, to -1, and to 0. Do you see how it's stretched out? Now, remember our original y equals the sine of x. Remember what it did. It started at 0, and then at pi over 2, it went to 1, and then at pi, it went to 0, and then at 3 pi over 2, it went to -1, and at 2 pi, it went to 0. So our original y equals the sine of x looks like this. But notice now what our new graph, y equals the sine of 1/2 x. It actually stretched it out. So the b is kind of backwards. The smaller b gets, the more it stretches it out long. And the bigger b gets, the more it'll push it in. So it's kind of backwards that way. So this red graph is the graph of y equals the sine of 1/2 x. Now, let's go to another example. Okay, so let's try this one. Y equals the sine of 3x. Now, again, let's identify A. A equals 1. B equals 3. So our period will be 2 pi over b equals 2 pi over 3, 2/3 pi. Ooh. Okay, so now when we go to do our little graph, it's not going to be so nice. We start with 0, and then at the very end, we're going to have 2 pi over 3. Ew. Okay, so to find out what your in-between points are, you want to take a quarter of 2 pi over 3. So you take 1/4 times 2 pi over 3, and you get pi over 6. That is your first quarter right here, pi over 6. Okay, now you can just take your pi over 6 and times it by 2, and that's going to equal pi over 3. That is your next point, pi over 3. Then you can again take your pi over 6, your first quarter point, and times it by 3, and you get pi over 2, and that will be your point between these two. Okay, so those are our 4 points, as strange as they look. Now we just do the same thing again. We start with our 0. Y equals, let me erase that. Okay. Undo. There we go. Let's just do this. Y equals the sine of 3x. So we're going to start at x equals 0. So we would have y equals the sine of 3 times 0 equals the sine of 0. And what is the sine of 0? 0. So our graph is going to be 0. We start at 0, 0. Now let's do pi over 6. So if x equals pi over 6, we get y equals the sine of 3 times pi over 6 equals the sine of pi over 2, or the sine of 90, which is 1. So pi over 6, we're going to 1. Now for x equals pi over 3. Y equals the sine of 3 times pi over 3 equals the sine of pi. And what is the sine of pi? 0. So we get pi over 3, because remember that's our x, is 0. And you should be getting the pattern here. Remember what I originally told you about the sine curve that really helps. Do you remember when we did the original sine curve, how the zeros were at 0, pi, or the beginning value, the ending value, and the middle value? And then the first one between was 1, and the one between the last two was -1. It's the same for each one, but I'm working it out to show you where it comes from. But you ought to be able at this point to realize that you're going to be able to do that graph in 2 seconds without working all this math out. So let's try x equals pi over 2. So y equals the sine of 3 times pi over 2 equals the sine of 3 pi over 2, which is 270, which is -1. So at pi over 2, we go to -1. And then lastly, let's do our x equals 2 pi over 3. Y equals the sine of, 3 times 2 pi. Y equals the sine of 3 times 2 pi over 3 equals the sine of 2 pi, or 0 degrees, which is 0. And again, our graph is going to, the sine curve is going to look like this. Okay. So do you see the only difference really are the numbers of the, or the values where our points are. Let's fix that a little bit there. That's a little bit better. Okay. You have your 0 at the beginning point, at the midpoint, and the end, and then you have your 1 between and your -1 between here. Again, that was because a equaled 1. Now, what would this look like? Let me ask you this. What would this look like? Y equals 2 sine of 3x. Notice we added an a. All that's going to change is your graph is going to go to 2 and -2. So you'll still have your point at 0, pi over 3, and 2 pi over 3. They'll all be 0. But your pi over 6 will go up to 2, and your pi over 2 will go down to -2. So your graph would look like this. See the difference? Now you can see what A does and what B does to the original graph of y equals the sine of x. It is the same procedure to follow for the cosine. Hopefully this helps clear up how you graph these things.